Okay, guys, we're going to look at the lecture that's called Look What's Trending. We see we have hashtag because of chemistry. And so the quote that we have is, "Don't follow a trend, follow your heart." Looking at the learning goals for this lecture, students will understand the relationship between the subatomic particles and periodic trends. Secondly, that students will understand the relationship between the periodic table shape and periodic trends. And then lastly, students will be able to predict the properties based on periodic trends. Those are our learning goals. Now, what we already know, there's no consistent pattern of protons, neutrons, and electrons in elements. We see that they change for isotopes and everything else. We see that their neutrons will change or electrons will change and everything else. And we know that the periodic table shows the trends in atomic structure, and we should know that it kind of shows their properties, and the chemicals chemical families have similar chemical properties. And so what we should have learned in the lab is that elements in the same column have the same number of outer electrons. We call those valence electrons. And that elements in the same row use the same outer electron level. And so the elements in the same row will have the same energy level. So let's jump into our periodic trends. Now, atomic radii, what that is, atomic radii, you can think of it, it's just, let's pick a different color there, it's just the size of the atom. And what we look at, it says as you move down the table, you are increasing the distance by adding another level of electron. So you have your nucleus right here, and as we move down, the energy levels, so down here, we just keep on adding electron levels, energy levels, that increase the size of the atom. And as you increase the size of the atom, it just gets bigger because the energy level gets bigger. Now, as you move from right to left, the number of positive charges increase. Okay, so from right to left, the number of positive charges increase. And since there's more positive charges, it pulls the electrons and shrinks the atom. Since there's more positive charges reacting with those negative charges, they're attracted to each other and they kind of pull close. And so they get smaller as they go this way. Okay, the one thing that we want to know for this is that everything gets bigger on the periodic table in size as we move in that direction. Okay, we move this direction, size gets bigger. So let's look at an example. It says lifts the following in order of increasing atomic radii. And so when we're looking at this, we know that we have our fluorine, which is F, which is right there. And then we have our chlorine, which is right there. And then we have bromine, which is right there. And so what we know is we want to list them in order of increasing atomic radius. So increasing means going from small to big. And so remember that everything increases this way. So they increase going down the periodic table. So fluorine would be our smallest, and then we would have chlorine, and then we'd have bromine, because they're going in this order. They increase as they go down. So increasing order is from small to big. Let's look at the next one. It says list the following in order of increasing atomic radius. So again, we're putting them from small to big. So here's potassium, here's calcium, and here's iron. So remember, because they get more protons, they get smaller, or the small guys are over here. Remember that they all increase in what direction? That direction, meaning it increases as it goes across the period this way. So the smallest is going to be fluorine, and then calcium, and then potassium. And that will be our order. So not fluorine, but iron. Iron is the smallest, and then calcium, and then potassium. Now, ionization energy. The definition of ionization energy is the energy that it takes to pull an electron away, to take an electron away. Now, an electron is attracted to the positive nucleus. So what we know is that all these negatives, all of these guys out here, they're attracted to that positive nucleus. And so what we have to do is energy has to go in to take that electron away. So energy is required to pull an electron away from an atom. So ionization energy is you're creating an ion. You're taking it from a neutral atom. Now, Ionization energy trend. As you move down the periodic table, it increases the distance between the protons and the electrons, which increases the pull between them, or decreases the pull between them. Okay? Ionization energy decreases as you move down the periodic table. Okay, so as we go this way, it decreases. Moving across the periodic table increases the charge of the nucleus and electrons, increasing the pull between them. So the more going this way, we have more positives, so therefore the negatives are attracted to more of those positives, which makes it harder to steal that electron basically. So ionization energy increases as you move across the periodic table. The one thing, remember we said that atomic radius increased that way on the periodic table. Well, ionization energy is the opposite. Every ionization gets bigger as you move that way on the periodic table. So it gets big as you go up, and it gets big as you go to the right. So it increases that way. So let's look at an example. It says list the following in order of increasing ionization energy. So we have our lithium, we have our sodium, and we have our potassium. So they're in the same family. They're in the same column on the periodic table. And remember, ionization energy increases as you go up and as you move to the right. So in this case, we're moving up. So it increases as we go up. So from small being down here to big being up there. So potassium will be the smallest, and then we would go sodium and lithium. Lithium would have the highest ionization energy. So let's look at the next one. It says list the following in order of increasing ionization energy. So we have our aluminum, which is right there. We have our silicon, which is right there. And we have our phosphorus, which is right there. Now remember, it increases this way and up. So we go from aluminum being the smallest ionization energy to silicon being the next one, and then phosphorus would be our last, and that would have the highest ionization energy. Next periodic trend that we have is electron affinity. Now electron affinity, free electrons can be captured since they are attracted to a positive nucleus. So electron affinity is energy is not required to pull the free electron to the atom. So what happens is electron affinity is the energy that we have when an electron is captured. Okay, so it's captured and we have an energy there. Okay, now electron affinity trend. As we move across the periodic table, it increases the charge of the protons, therefore increasing the pull on a free electron. So if there's one floating around there, it increases the charge. Now electron affinity increases as you move across the periodic table. Okay? And then moving up the periodic table decreases the distance between the positive nucleus and the free electrons, which increases the pull between them. So electron affinity increases as you move up. The main thing, electron affinity increases that way. So it increases as you move up and it increases as you move right. So it's basically the same as your ionization energy. It increases that way. So let's look at an example. It says list the following in order of increasing electron affinity. So we have fluorine, we have chlorine, and we have bromine. So remember, they increase as they go up. So the smallest electron affinity is going to be bromine, and then you're going to have chlorine, and then you're going to have fluorine. Look at our next one. It says list the following in order of increasing electron affinity. So we have potassium, we have calcium, and here's iron. And so remember that electron affinity increases as you go here and as you go up. So our smallest electron affinity is going to be potassium, and then it'll go calcium, and then it'll go iron. Iron would have the highest amongst those three. Our last periodic trend that we have is called electronegativity. Now, electronegativity is a measure of an atom's ability to pull another electron, similar to electron affinity, that depends on the outer electron distance from the nucleus and the number of protons. And so what electronegativity is, the main difference between electronegativity and electron affinity is electronegativity usually exists in a bond. So we talk about electronegativity being in bonds. So when something is bonded to another atom, we look at the electronegativity, and the more electronegative substance is going to pull on electrons. So it's the pull on another element's electrons. So let's look at the electron affinity trend. Moving across the periodic table increases the charge of protons, which increases the pull on a free electron. Okay, so it increases going this way. And then moving up the periodic table decreases the distance between the positive nucleus and the free electrons and increases the pull between them. So it increases this way. So electronegativity, ionization energy, and electron affinity all increase as we're going up the periodic table. Now, the one thing that we should pay attention here, the main difference between electronegativity and electron affinity and ionization energy is that electronegativity, we don't have those for the noble gases. So think of this as being group 18, those guys are gone. Okay, so electronegativity increases towards fluorine. Fluorine is going to have the highest electronegativity, and then everything else is kind of based off of fluorine. So let's look at an example. It says list the following in order of increasing electron affinity or electronegativity. So we have lithium, we have sodium, and then we have potassium. And remember, it increases this way. So it increases up and increases to the right. So the highest or the lowest would be potassium, and then we would have sodium, and then we would have lithium. Next one. It says list the following in order of increasing electronegativity. We have aluminum. We have our silicon, and we have our phosphorus. So remember, it all increases towards fluorine. So increases across, so it's going to go aluminum will be the smallest, and then silicon, and then phosphorus. And those are going to be our periodic trends. So to recap all of these, the one thing that we got to pay attention to is that atomic radius increases this way, and every other periodic trend increases the opposite direction. Okay, so atomic radius increases as you move that direction, and then ionization energy, electron affinity, and electronegativity all increase the opposite way.